is live with us from DC at an event down there. Jim, real quickly, to the right of you on the screen is the actual live image that's being fed back by a lunar craft, and so we're going to see it impact shortly. Why are they doing this today?
What we're doing is to really understand how the moon works. And this is the place we're going to learn to live off planet, to be our beachhead in deep space. We got to understand what's there, what are the resources we can use, and scientifically, really, how does the water work? I mean, we know there's evidence of that on the moon, but how much, how deep? And so this impact will actually do that for us.
All right, Mr. Governor, stand by. We're 20 seconds away. We're looking at an image from a lunar probe, and down there somewhere, closer to the moon, is an actual 2.2-ton rocket that's going to set off a big plume. Should happen shortly. Let's listen and watch.
Please change NIR1 to OPR9. Over.
Copy NIR1 to OPR9. Command flight setup. Set November or Mike.
We are, the science team is now communicating to the flight team to adjust some camera levels.
Flight confirmed near infrared. November, correct?
On our near infrared camera.
Send NIR1 to OPR9. Copy. Sending command. All stations flight. Mark Centaur impact.
That was an announcement by the flight director that the Centaur impact should have
Confirm receipt of command over. Flight payload current start over. Copy that payload.
We should be looking for some signs of the impact on the leftmost part of the
With mid-infrared changes.
the left side of the shadow, right below the dimpled crater on the crater, the larger crater rim. Flight, this is science. Make the rate changes. MIR1, 1 hertz. MIR2, 0.1 hertz. Over.
Copy science command flight MIR1 to 1 hertz. Sending MIR1 at 1 hertz.
And the science team is directing the flight team to adjust the sampling rate of some of the instruments to fit within the 1 megahertz.
Ready with MIR2 at 0.1.
The 1 megahertz signal limit.
Command flight send MIR2 0.1 hertz. MIR2 0.1 hertz.
There's going to be a second impact, but we understand even though it was not detectable by our eyes, there was an impact, and it seems, according to some of the jargon we heard, to have been successful. Jim Garvin is with us, a former NASA scientist. Jim, we're trying to pick up what happened. What can you detect? Well, we're waiting for the first sign of the flash that we'll see with one of the 9 instruments on the L-Cross shepherding spacecraft. And meanwhile, the observatories on Earth, including the one in Earth orbit, Hubble, is watching these for the signature of this plume, this curtain of debris that has been jettisoned by this 2.3 metric ton impact. So that's where we are.
But Jim, is it your understanding that it has successfully impacted? Because it doesn't sound like we've seen a plume.
Much more quickly. Pointing at that Centaur impact point, even though the...
So, Jim, this right now is the point of view from the L-Cross lunar probe. It's going to crash into the surface of the moon in about a minute and a half or 2 minutes. And it's supposed to fly through all this 6-mile-high debris field. And it's at that point that the craft will detect whether or not there's water in the atmosphere.
Right, Jim Garvin? Yes, that's one of the ways we can tell. The shepherding spacecraft has instruments in the near-infrared, the mid-infrared, that can detect the signatures of water in different phases, particularly a gas phase. So we'll see how much is there, down to 1%. We can now see the event coming on behind me right now. And then other observatories will see the effect after the fact. What would you say, Jim? You think we just saw the dust plume?
NIR2, OPR.
We just saw it.
So the
So now we're changing the rates on
refer to it, flying into this great big dust cloud.
Right. What we were seeing was the flash of the impact of the big empty upper stage on the moon, the force of several hundred pounds of TNT, and then watching that flash with the shepherding satellite following 4 minutes behind.
Now, Jim, tell us the significance of this today.
They're getting very close.
Oh,
Okay. Great. We're getting the temperature signature of the pulse from the impact, as we expect. Several hundreds degrees increase in temperature in this very cold place. Okay, we've lost signal now on the Shepherd. Okay, so the primary mission is over now. So now what we're doing, within 1 minute, the Lunar Reconnaissance Orbiter is going to fly by and look sideways using starlight imaging to see what was in that probe.
Jim, we see everybody standing and clapping, so it seems as though NASA considers this a success. What's just happened?
I think we have a little bit of humor here in the building. This is actually the end of the primary L-Cross mission, but now the fun begins for science as all the observatories on Earth, Hubble, and LRO begin to take their data and play it back. So within 2 hours, we should have data from the Lunar Reconnaissance Orbiter's far ultraviolet spectrometer to see what it saw in the fluid.
Right, and of course, if anyone saw water, bingo.
Right. And the fact that we got a thermal signature means that we have this sensitivity to see whether it was there. That's a really good sign from this experiment. And, in a couple of weeks, the Lunar Reconnaissance Orbiter will fly right over the crater we made and image it and with lasers and cameras, temperature mapping, and radars.
Interesting stuff. All right, Jim Garvin, former NASA chief scientist, we thank you very much. He was at an event at the museum in Washington, D.C. Meanwhile, there's another event from Moffett Field, California. Claudia Cowan has been following the story, and she's out there with a whole bunch of people who are crazy about moon stuff.
Yeah, I've got data with me. I've got data right here. This is Brian Harbinson from nearby Los Gatos, not far from the NASA Ames Research Center, where we are this morning, which is in charge of the L-Cross project, and where hundreds of people, including families with little kids, camped out overnight for this particular viewing party. So, Brian/Data, what time did you get here?
I got here about 12 o'clock this morning.
And did you see the impact just now on the big screen?
Well, they said it impacted, but I didn't see anything.
Okay, but this is still a great opportunity for young people, especially, I would imagine, to become more interested in space exploration and science.
Absolutely. This is an event I didn't want to miss.
And you go out and you spread the word about space and Star Trek, and you go to parties and get kids interested, right?
Somewhat, yes, absolutely.
Okay, well, you felt it was important to dress up for this event.
Yeah, a bit of a turkey shoot for what it is that I'm wearing for this event.
All right, well, Brian/Data, thank you for your time. A lot of people out here camping out all night, also at other observatories around the world. We were out at the Chabot Space and Science Center yesterday in Oakland. They were expecting several hundred people there. A lot of excitement about this historic lunar experiment.